Welcome to our first video of the year. We're going to start off by looking at the preliminary chapter, specifically P1 and P2. So for P1, we're looking at solve. And to start off, I want to remind everyone that when we solve equations, we usually start with variables on both sides of the equal sign as well as numbers, and then we want to transform them into what's called equivalent equations to where we can get it so it's just one variable on one side and a number or an answer on the other side of the equal sign. So if you look at the first slide that we have here, we're looking at steps for transforming equations into equivalent equations. So we've got 4 different methods we can go through. The first one is removing symbols of grouping, so that would be squares and parentheses, combine like terms, or simplify fractions on one or both sides of the equation. For number 2, we add or subtract the same quantity to or from each side of the equation. And for 3, we multiply or divide each side of the equation by the same non-zero quantity. Lastly, number 4, interchange the 2 sides of equations. So that may mean you have the variable on the right side of the equal sign, you want it on the left, so you just switch sides. Go ahead and look at some examples. We're going to start off by looking at 20. Okay, in 20, our original equation is 9x minus 10 equals quantity of 2x minus 5. So first thing I'm going to do is I'm going to do that first step that we saw on the list on the last slide, and I'm going to transform my equation to an equivalent one by getting rid of those parentheses on the right side. So I get 9x minus 10 equals 5x plus, and so I'm going to distribute the 2 to the 2x and the negative 5. So I get positive 4x minus 10. Next thing I'm going to do is combine like terms. So I get 9x minus 10 equals 9x minus 10. Both sides of the equal sign are the same, so if we continue to simplify, we'd end up with 0 equals 0. This is an identity, okay? So our answer is just identity. That means no matter what number we put in, we're going to get the same answer on each side because they're the same. Let's go ahead and look at 22. In 22, we've got the equation x over 5 minus x over 2 is equal to 3 plus 3x over 10. We're going to use that first step again by getting rid of fractions. Now, in order to get rid of fractions, we're going to find the LCD. If you remember, LCD is least common denominator. So the least common denominator here is 10. And to remove the fractions completely from my equation, I'm going to multiply both sides by 10. So when I do that, I get 2x minus 5x equals 3 plus 3x. So all I did was multiply 10 to each fraction as well as the number 3, so that's 30. Okay. Next, we're going to combine like terms on each side. So I get negative 3x equals 30 plus 3x. And I'm going to subtract 3x from each side, so I get negative 6x equals 30, so x is equal to negative 5. We should always check our solutions just to make sure they work. So for the check, I'm going to plug in negative 5 everywhere I see an x in the original. So I get negative 5 over 5 minus negative 5 over 2 equals 3 plus negative 15 over 10. So this then becomes negative 1 plus 5 halves equals 3 minus 3 halves. Common denominator is 2, so I'm going to multiply everything by 2. Negative 2 plus 5 equals 6 minus 3. This will be 3 equals 3. That's correct, so our solution is an answer. Next, we look at 36. In 36, again, we have another fraction, but this time our LCD is not a number. Instead, our LCD is an expression. Specifically, it's going to be x times x plus 3, which if you were to distribute, that would be x squared plus 3x. Okay, so I'm going to multiply everything by x times x plus 3. When I distribute that through, I get 6 times x plus 3 minus 2 times x equals 3 times x plus 5. I'm going to get rid of those parentheses, so I get 6x plus 18 minus 2x equals 3x plus 15. I'm going to get a common denominator on the left. Sorry, I'm going to get combined like terms on the left. So I get 4x plus 18 equals 3x plus 15. I'm going to subtract 3x from each side. So I get x plus 18 equals 15. And I'm going to subtract 18 from each side. So I get x equals negative 3. I'm going to check this answer. So I'm going to plug this negative 3 back in to the original. So I get 6 over negative 3 minus 2 over negative 3 plus 3 equals 3 times negative 3 plus 5 over negative 3 squared minus 9, because that's 3 times 3. Okay. When I do this, I get negative 2 minus 2 over 0 equals negative 3 plus 5 is 2. 2 times 3 is 6 over 0. You cannot divide by 0, so this is not a solution. So our answer is no solution. Lastly, we're going to look at 66. 66, we've got the quantity of x plus 5 squared is equal to the quantity of x plus 4 squared. The only issue with this is I think the first natural thing to do is to take the square root of both sides. We're not going to do that, and I highly suggest you don't. Just because when you take the square root of both sides, anytime you put a square root in, you have to add the plus or minus, and that's going to make this difficult. So instead, we're going to FOIL out. So we get x squared plus 10x plus 25 equals x squared plus 8x plus 16. I'm going to subtract x squared from each side, so I get 10x plus 25 equals 8x plus 16. I'm going to subtract 8x from each side, so I get 2x plus 25 equals 16. I'm going to subtract 25 from each side, so I get 2x equals negative 9. X is equal to negative 9 halves. And I'll let you guys do the check on your own, but when you do check this out, it does work. So our answer is negative 9 halves. Next, we're going to look at P2, which is on solving inequalities. So quickly, I want to review the difference between bounded sets and unbounded sets. In bounded sets, our list here, which has is from 0 to 1, okay, with open parentheses. That's going to be an open set. We've got 2 to 3, open, because it's got the parentheses here, and then close, because it's got a bracket there on the 3. So if we were to write that in interval notation, that would be 2 less than x less than or equal to 3. Okay, so the bracket tells me that's also equal to 3. The answer can also be 3. So then we have the set from the interval from 3 to 6, where it's closed on 3 and open on 6. And then we've got the entirely closed set 8 to 10. These are all bounded sets because eventually they're going to end. Now, if we look at unbounded sets, we've got 0 to infinity, negative infinity to 3, and 4 to infinity. If you notice, whenever you have infinity, you usually put a parenthesis there. This is because infinity is infinitely large. Okay, so that means that it's just going to keep going on and on and on and on forever. That's what makes it an unbounded set, because it's bounded on one side but not on the other. So we're going to start off by looking at 8. We've got the interval from negative 7 to 4, and they want us to first write it in interval notation, and then to determine whether it's an unbounded set or a bounded set. So interval notation of this would just be negative 7 less than x less than 4, because we want all numbers in between negative 7 and 4, non-inclusive on negative 7 or 4. So that's why there's no equal signs. This is an bounded set. Okay, because there is no infinity involved. 12, we have the set negative 5 to infinity. Okay, just going to start off by saying this is unbounded because of the infinity there. And then we're going to write this in interval notation. This essentially is saying that it's this x value that we're looking at, this variable that we're going to name x, is any number that's greater than negative 5 or equal to negative 5. So if we were to write that, we would just say x greater than or equal to negative 5, because negative 4 fits in that interval, negative 3, 100, 120, all the way up to positive infinity. Next, we're going to look at 40. in 40, we've got the inequality 4x plus 4 greater than 2x plus 3. And we're just trying to solve this inequality for the variable x. So we're going to try and get x on one side and everything else on the other. And then we're going to draw that on a number line. So the first thing I'm going to do is use some of those strategies that we did in the previous lesson. And I'm going to subtract 2x from each side. So I get 2x plus 4 is less than 3. Then I'm going to subtract 1 from each side. So, sorry, 4 from each side. So I get 2x is less than negative 1. And I'm going to divide both sides by 2. So I get x is less than negative 1/2. So what I'm going to do is I'm going to draw a number line here. Write down my negative 1/2. Open circle because it's not equal to. And then an arrow towards all numbers less than negative 1/2. Look at before looking at more in class is 50. For 50, we've got the interval 0 less than or equal to 2 minus 3 times the quantity of x plus 1 less than. First thing I'm going to do is I'm going to get rid of those parentheses in the middle by distributing that negative 3. So I get 2 minus 3x minus 3 less than 20. I'm then going to combine like terms. So I get 0 less than or equal to negative 1 minus 3x less than 20. I'm going to add 1 to each side. So I get 1 less than or equal to negative 3x less than 21. And then I'm going to divide everything by negative 3. So I get negative 1/3 greater than or equal to x greater than 7. Remember, when you divide or multiply by a negative, you have to flip your sign. Not when you add or subtract though, just when you divide or multiply. And so that's our new interval. So I'm going to rewrite this. So it's 7 less than x less than or equal to negative 1/3. So negative 7 less than x less than or equal to negative 1/3. So to draw this on a number line, I have negative 7, negative 1/3. It is equal to 1/3, negative 1/3, but not equal to negative 7. And then draw a line in the middle. And that's the video for today.